Yes, also warm welcome from my side, and thanks Ursula for this introduction. So as already introduced, my name is Christian Dülme and I'm the head of the product management for automated cabinet building at Weidmüller. And today we want to have a deeper look in the area of product data together with Achim Strehner from Zuken E3. But before we start with the topic of data itself, I just want to quickly highlight our initiative overall. So who is part in the initiative? Our Smart Cabinet Building Initiative was announced roughly 1.5 years ago. What was the starting point? We are totally convinced that based on the bundling of competence and know-how, we can provide you more helpful tools that you will be able to fulfill the requirements in cabinet building today as well as in the future. So who is involved? Weidmüller for the area of industrial connectivity, Comax for the topic of automated wire processing, Zuken for the digital engineering for cabinet building, and last but not least, Armbruster Engineering with this assistant systems for manual production. So what's the benefit out of this initiative? Together, these four partner companies can provide the entire process from engineering above logistics and mechanics, the different assembly steps, wire processing and pre-wiring, the cabinet assembly itself and the wiring, testing and service in the end, and everything end to end. For sure, especially the topic of data is quite important, and the focus for today is how do you get product data as simple as possible and which ones do you need for which application. And to show you some of these applications, we will switch to the next slide and I will show you a video to give you a little bit more practical feeling. So in this video, you see there are 5 different applications. So on the left-hand side in the upper corner, for example, you can find there the rail assembler for the automated terminal block assembly on a DIN rail. On the upper right-hand side, you see there our assistant solutions from Armbruster Engineering for adding further components as well as accessories on a terminal rail. And on the lower left-hand corner, you can find then the rail assembler, a rail laser, because after we assembled all components and accessories, we can automatically mark all markers on this configuration. On the lower right-hand side corner, you can find there the Comax machine who is doing the automated wire processing and can even support the process step of pre-wiring. Everything then comes to one place, and that is our assisted mounting plate assembly, again from our partner Armbruster Engineering, where we connect all of these kits and doing nearly the final assembly steps. So you see there, we have that huge range of different applications where we can make use of the data. So the question is, which data is required for what? So if you just share again the PowerPoint presentation, then I want to show you one example, and that is the interconnection and the interaction of data model and the use case. So on the left-hand side, you can find there a terminal block out of the A series from Weidmüller and a data model out of our Weidmüller configurator. So you see in the picture that we have there several different arrows. For example, yellow one, blue one. And for example, the yellow ones are representing an additional information, and this is the position of a marker at each terminal block. So each of these arrows is a so-called token information, additional information for further process automation. And why is that important and required? Because if we want to do the automated marking process, we have there our image processing inside the rail laser, and this image processing is analyzing for each marker the real position, compares this with the position in the digital twin, and is doing fully automated a required adjustment that we have a perfect print result in the end. But for sure, the machine needs to know for which positions they need to search. And this information we can only get from a data model as shown on the left-hand side. But that was only one example. We have there several additional examples, and for sure the question where you can find the data is still open, and that will be answered by Achim Strehner from Zuken. So welcome, Achim.
Thank you, Christian, for the introduction and the nice example. I want to go a little bit in detail, which data you need for which processing step. Often the first automation in the cabinet building is the mechanical processing, for example, with such a enclosure and mounting plate processing machine. And there's not really lots of data needed to use this on this machine. What you need is just the article number and the dimensions of the basic elements. So in this case, a mounting plate or an enclosure, and you need the position and the size of the holes and the type of the holes. Is it a normal hole or is it a threaded hole? And if you have cutouts, then also the size and the position of cutouts, and for identifying afterwards some labeling information. Typically, you have two types of components on such mounting plates. The cable ducts and mounting rails, who are in the dynamic length, they typically has a definition of the holes, where it's the starting point and which step the next hole is located, and the size of the hole, and so on. And for other components who are not dynamically, who are like such a connector who is placed on the surface of this enclosure, they need information about the drill holes for the mounting. In this case, we have 4 drill holes. These are on the 4 corners, and we have a cutout. In this case, the red highlighted cutout who has to be cut into the enclosure. So if we have these information of the drill holes and the cutouts, and for the drills on dynamic components, if those are defined on the product data, then it is enough to place just those components on your digital twin, and all other is done by E3 and the cutout tool that can be automatically created such a mechanical drawing, and of course the data to import on such a machine. Who is the and where are the drill holes and the cutouts? So for doing drill holes and cutouts, you need the article number, and with the article number, the dimensions, and just some information about drill holes and cutouts. So very less data for a good first step of starting into the automation in the cabinet building. The next one is such a cutting machine for cabling, cable ducts and mounting rails. You only, in your product data, only need an article number, and with this article number also the size of and the type of the product. The length and the labeling information is coming from the project. You don't have to do anything in the product data. And if you have those 3 informations, you can send this to the machine, and there's an automatic adjustment so that you can cut these article on the right length. And to have a better identification afterwards, then you can print such a label with the device designation, maybe some other project information, and you can put them on the cable ducts or on the mounting rails for identification. So this is really very less data for using such automation. Coming to the next step is the production of terminal strips, and not only terminals. So on those mounting rails, other components can be plugged, and for your high runner products, you can use some robots or machines like the rail assembler, and there you can automatically place all the products on your terminals, on the terminal rails, and those products are not the high runner products, or maybe cannot processed by the machine. Of course, they are maybe too big or something else. Then the system is automatically doing some empty space, and this empty space can then be completed by our assisted solution with the ELAM workplace. There you get a digital information of all components who have been assembled on the pre-assembled terminal strip. So for example, to add some cross connectors or some other bigger components or some markers who are not assembled on the rail assembler, then you can do all the steps to finish the terminal strip with this assisted system. To do that, you need the article numbers of all the products. Of course, it helps in E3 if you have slot descriptions, then there's an automatically pre-check that all the components fit also on this terminal, on this mounting rail. Then we need the exact position of the mounting rail, but this is also done by E3 series. You need for some accessory information about cross connectors and so on, then to assemble, and maybe some identification for the device designation of this terminal rail to print a label that you need in the further step where to place, how to identify. So some more data, a little bit other data, but the most of that is done by the machine, and you only need those data, product data, in your system. For the automatic labeling, there are different solutions available. In the first step, the rail laser doing the fully automated printing on the text on the labels. In this case, you can put the whole mounting rail with all the components and the emptied markers on it on the rail laser, and within the data model who is inside of the Weidmuller configurator. So you don't have to care about the data. The data is available, but just for information, we know exactly where the position of this marker is. We know the vectors, so from which angle it has to be marked. And so this is all the data is available for the product of the Weidmuller product. So this is you don't have to care, and the position and the sequence of the mounting rail comes from E3. So this is really finished. If you do an assisted labeling, so not the labeling and the marking with the assembly. So if you do it manually or with an assisted workplace, then you need additional the item numbers of the marker items. So which article has to placed where. So the placed where is the position. This is also defined then coming from E3, and then you can see, okay, in your assisted system on the monitor where you have to plug which marker. And if you do it with such printers, this is a very common use case, then it helps a lot if on your base element, so your contactor or your terminals or something else, has a list of available or suitable markers, and with a definition who is the most suitable or it's my favorite, the E3 or the export can automatically adjust the correct or the best fitting marker, and you only have to define in your project those markers who divide or differ from the favorite. So this will help if the product data has the information, okay, on me as a terminal, those markers can be used and they fit all, and if there is no special definition, then it always uses the favorite markers, and the user don't have to care about that for maybe 95% of the markers in your project, and you only have to define it for the special 5% who you really want for special purpose, a special marker. Then you have defined it, and for all the other cases, it's automatically done. In the case of production of wires, there is the possibility to define these crimp parts, and you can let this do by E3 automatically. In this case, you need on the component pin to be acceptable, a list of available crimp parts, and normally you have a range of cross sections from 0.5 to 2.5, for example. So maybe there are 10 different crimp parts available or 3 different crimp parts available, and you should do a list. And depending on which wire, the cross section and the outer diameter of the wire who has to be connected to this pin, the correct crimp part is automatically calculated, and the user do not have to care about that. So if you want to use this, you should have in your product data the list of possible crimp parts. The crimp part itself has to be defined with the inner and the outer diameter, so that we know it fits for which cross section. And on the wires itself, you also have to define the cross section, but this is state of the art. If you have those information defined, E3 does everything for you, and you only have to switch maybe the gold contact to a silver contact if you want not the favorite gold contact. But if you always use the favorite, then you don't have to care about that. And if it is no problem if some of your components do not have those crimp parts defined on the pin, then all the exports has a plan B. Maybe, for example, if there is not known which crimp part has to be done, then you can do, for example, a pull-off or something else, and you have to complete this wire end by connecting it. But you can produce those set of wires, the length, and with the marking text on the ends, for example. Also, and if you know the article number of the crimp part, then it can be done on such a machine. If not, you have a plan B. And for the length, you just need the part numbers of the cores and the cross section, and the length is coming from E3. The core end treatment we see it is defined, and if you have also the optional labeling, it's also it's done automatically by E3. You don't have to care about. Product data necessary for summary, crimp parts, and cross sections. To avoid errors in the designing of a cabinet, it helps if the component has the dimensions. So then we have automatically a collision check, so that there is not too big and not too small. So we know, okay, if it can be placed in the E3 digital twin, then it also fits in the real life. Very important information who can help is the slot, so-called slot definition. And there is defined on which mounting rail or something else I can place, and which components can be placed on me. So and which position. So this is a very helpful information to make the designing of such a cabinet much faster and efficient, and increases the quality. Then there is a possibility to have such blocking areas, for example, or if you have a heating, you need some space for the heating or something else, you can define that so that no other component is placed too near to such a component. And if you want to do the mechanical stuff for all components who are not plugged on a mounting rail, they need the information of the drill holes and the cutouts. And for the routing, this is necessary for doing the wires. It helps that you need of every connect point how many wires can be connected on this pin, which is the minimum and the maximum cross sections of these wires. Maybe if there is a direction predefined, and last but not least, but this is very optional, you can define a signal on this pin that maybe a plus is not connected with a minus. So if you have these data, you can create your digital twin very efficient, and you are sure that the quality is very high. So if it fits in the digital twin, then normally it fits also in the real world. So if you have those data, then you can do that. I talked a lot about necessary product data. Then there is always the question, where can I get these? My recommendation is the E3 Component Cloud. We try to get all the data from the manufacturers into this component cloud, so that you have only one location where you can get the data. So this is our favorite. If there is some components missing, or the component is there but some special product data, some properties you need for your automation is not defined, then you can call such service providers who do this for you, or you can do it, of course, self in the database editor. So it is not a blocking point. If there is some properties missing, you can help yourself, or you can let you help from service providers. But in the ideal world, you can load it from the component cloud. And that this is not a rocket science. I have also a video showing this. As you can see, this is a E3 running with an empty database, and starting the component cloud, you have just a register. This is for free, and then you can search for an article number or something else, and then you find your needed component. You see a preview, and if there are some properties defined, then you can see it. Then you can generate all the necessary data. If you only want to use it for cabinet manufacturing, it is good to have only the model, the physical data. This is enough. You don't need all the schematic symbols. So, and in the background, you saw it is loading or creating this component with step model, with all the information for the bill of materials and so on, with the views of the from right, from left, from top, from bottom. You see the slot definitions, you see the pin definitions. An example on this pin is 1 wire available, and from cross section 1.5 square millimeters to 50 square millimeters, and it is clamped. So data is getting more and more available in such digital platforms, and try it to look first on that platform like Component Cloud, and loading the product you need. So some tips at the end. Product data is fuel for modern control cabinet production. You have seen what it is state of the art, what is available for that, and what it is, which product data is needed for which process steps. So focus, that's my tip. Don't care about data you don't use, you don't need. So focus on that data you really need. If you want the mechanical production, then look for the cutouts and the drill holes. And if you want to do the wire processing, then care about your crimp part definition and pin information for cross section and wire counts. So you do not need the complete properties of a component if you only want to use it for, or start with one or two automated or semi-automated production. Then focus on that. Then very important to keep the component manufacturer on track, that they deliver these product data for us all. Is there is the best possibility if there is some missing data, that the whole component is missing, for example, or some data of an existing component is missing, then please click in the component cloud for this vote for more catalogs, and then you can give some information. I need from company X the Stereos Y, and then this is a very good motivation. Then we or our partner Cadenas can go to the component manufacturer and give them a list and can say, okay, 10 big customers has voted that you have to deliver the data they want, that then they really do that. If there is no need for catalogs, then they won't provide those data. And for your own information, or for your colleagues, please watch those videos from our live event we recorded in May. There is a really nice overview of all the possibilities of the state of the art of modern cabinet manufacturer. It's a really a live video recording, which you can see all the machines and the interfaces and the digital twin and what has to be done for what. So I think it's a very impressive video, and yeah, this you can look at it. And with that, I want to hand over back to Christian. And
yes, Achim, thank you very much for giving us the insights on the topic of data. I think it will be a topic that will be part for sure also in the future due to this high relevance, and for sure also the relevance for further automation, but also the relevance which data is key for which application to have the right matching. Maybe you have some questions. For sure you can type them in our chat function, but additionally for sure you can contact us personally. So you can contact Achim or myself, and for sure additionally also the representatives from the other partner companies, so Cornel Dura from Comax as well as Timo Tessin from Armbruster Engineering. Hopefully you enjoyed our roughly half-hour trip in the digital data world. If you are interested in other topics, it's very useful to have regularly a look at our smartcabinetbuilding.com website, because there you can find also the additional webinars which will follow in the future. So normally these webinars will take place at the last Wednesday of the month, but due to the fact that we have there the SPS fair end of November in Nuremberg, we adjusted the timing for the webinar regarding the marking support in E3 series and the new Printed Connect from Weidmuller, and that webinar will be held at the 17th of November. But please have also the SPS fair in your calendar, because there we have again the chance for meeting us personally. So for example, Zuken will be there, and on the Zuken booth you can find also then the assisted mounting place from Armbruster Engineering. Also Weidmuller will be there on the SPS and Comac, so it's really a nice way of meeting us again personally. And also maybe already mark now the 2nd December this year in your calendar, because right now you saw during our presentation that we have there 4 partner companies in our initiative, and I can announce already that our initiative will grow. So who is our new partner and why and what we will do together with them? Let's wait for the 2nd of December and already mark it now in your calendar. And for sure, please forward also this information to any other interested colleagues, that also all relevant players have the information available. And based on that, I would like to thank you again for your time and interest. And now it's a time for questions from your side.